Today we're talking about Istio, and the title for the presentation is Istio is the future. And that's kind of a hyperbolic statement, but it's not unusual for tech conferences for people to make these sort of hyperbolic statements. If you're not doing this, you should be doing that. But I do feel comfortable saying Istio is the future because I do believe that it is the future. If it's not Istio, it's going to be something like Istio. So hopefully, after we're all done with this presentation, I got to put my glasses on. I can't see my own notes. Hopefully, when we're done with the presentation, we'll be able to. You guys may actually have the same belief that I do, that Istio is the future. So a little bit about myself. My name is Jason Smith. I'm a senior engineer at Container Solutions. I've been with Container Solutions for about 2 years. We have a table sitting outside. It's the one with the racetrack and the bike where you can race your friends by pedaling. Come by and visit. We do a lot of cloud-native, container-based consulting. So I wanted to let you know ahead of time, I'm not going to be doing any demos, and I'm not really going to be getting into features per se. I'm not going to be going through a list of features. What you will see, though, is when I present the concepts I'm going to present, you'll see that the features are going to be outcomes of those concepts. I am going to be talking about Istio at a much higher level. So some quick background. About a year ago, it was announced that these three companies were going to do a joint venture, IBM, Google, and Lyft. We're going to do this joint venture for this product called Istio, and it was going to be a service mesh. The reason that Lyft was involved is because they had created Envoy, and it's a proxy that Istio is using. After the announcement came out, there was a lot of buzz about Istio. A lot of large companies were embracing the idea of Istio, but I've noticed, since I've been tracking it since the beginning, is a lot of people don't understand what the benefit is, what value it's bringing to their system. So the point of the presentation is hopefully we can get to some of those value propositions. Sorry, I got to clean my glasses. So I'm going to try to illustrate why it is important. So I'm going to cover three basic concepts, and the very high-level concepts that I feel that Istio is embracing. Hopefully some of these will answer the question why. One of them being abstraction, one of the most common terms we'll hear at a tech conference. The other being intelligence. And finally, making Istio extendable, or the fact that Istio is extendable. So let's talk about abstraction. It is, like I said, one of the most overused words probably in our field, but it is important. But before I get into how Istio abstracts things, I want to talk about something that we've all been using, or some of us have been using for a while now. And it's a relatively new product as well. Kubernetes. Do I have a show of hands of anybody that's using Kubernetes in production? All right. Well, sorry. Kubernetes introduced a new way of doing things. The old way of doing things was we would manage our VMs. We would usually manage them individually. There was usually a tight coupling between the application we deployed on our VMs and the VMs that we were running. Now, we did improve this situation eventually by introducing config management, by using tools like Puppet, Chef, Salt, and Ansible. But we were still naming our machines. We would still name it after Star Wars planets or Star Trek ships or any other number of reasons because we were attached to them. Now, when the cloud became more prevalent and we started embracing the cloud, we started giving up on that idea. And we did start embracing the idea of cattle and cats. Like, our machines are now cattle. We can destroy them and bring them back up, and it's not something we're going to nurse back to health anymore. It's something that is not a value in its own. It's what you deploy on it now. So with containers, what Kubernetes has done is it abstracted that VM away from you. By putting containers and deploying them using Kubernetes, what we've done is we've abstracted the basic concept of the VM and the multiple VMs, and we've made them a pool of resources that we can tap into of CPU and memory. And it becomes a pool of workers, and they all sort of act the same now. We don't have to manage individual ones. And the architecture for Kubernetes was you'd have this control plane, and then you have these worker nodes. The worker nodes were sort of dumb nodes. They weren't, you don't manually manage them. Kubernetes manages them for you. And you can destroy and bring them back, and you don't nurse them back to health. If they're acting up, you get rid of them. And the concept was that you had this one arbiter, this control plane, that would just sort of tell these machines how they should operate. Istio also has a control plane, all right? And it also has what they call the data plane, which would be the equivalent of what we're doing with nodes on Kubernetes. This data plane is our level of abstraction. This data plane is designed to operate on top of the network. It knows it's operating on a network, and it knows all the problems that come along with operating on that network. It knows that networks have problems, and it knows how to react to them. So if anybody's used this, has anybody used Istio before? Anyone? Just put your hand up. So if you did this, the practical exercise that you get on Istio, and you go to their page and you deploy it, what you're going to get is this. It's pretty basic summary of what it's doing. You deploy your apps. You put your sidecars in. The sidecar is the envoy, all right? And then it would just be routing your traffic over the Kubernetes network. And this is actually a correct representation of what's going on with Istio on Kubernetes. But what we have to understand is, even though it was designed with K8s, and that was like its breaking territory, and that's where it came about to be, it was integrated with K8s, it worked well with it, it did service discovery using the tools that Kubernetes provided. Kubernetes is not a requirement for Istio. Right now it is, but long term it's not. Istio is actually agnostic to the platform it's running on. So what we see here, this is our data plane. It is managed outside of wherever it runs, and it's its own entity. And this whole sidecar pattern, this isn't specific to Kubernetes. This is just a microservices pattern. So that means we can do it almost anywhere. So in theory, we could run it on DCOS. We could run it on Amazon ECS. We could run it on Nomad. And we could run it on virtual machines. And we can run it on bare metal. So this level of abstraction is important, and it's going to come back a little later on some of the features that Istio is going to offer, and I'll return to the bare metal soon enough. So the second point I wanted to bring up was intelligence, but I'm not just talking about regular intelligence, I'm talking about operational intelligence. And what is operational intelligence? Usually it's used in the business world, but if we go to Wikipedia, which is the source of all my information, it provides real-time dynamic business analytics. It provides visibility and insight, and it gives you the ability to act on those insights, either through manual or automated actions. So has anyone here read the Google SRE book? All right. So the Google SRE book utilizes operational intelligence. They're using that same concepts that we saw on Wikipedia to automate and monitor and keep track of how their system's operating. And then it helps them not only make automated decisions in their infrastructure, but it also helps them make business decisions. When they talk about things like SI, SLIs, SLOs, SLAs, these are all based on the measurements that they get from the business intelligence they get from the infrastructure that they set up. Now, Istio provides us that. Istio is heavily integrated with Prometheus. It tracks all the metrics of the traffic that's going over the wire for you. And by doing that, it gives you that operational intelligence. It gives you fine-grained metrics for all your network traffic, and these, like I said, help you achieve operational intelligence. Using these metrics, right, this telemetry that we have, we can do things like automatic invariant deployments, automatic provisioning of new resources, automatic destruction of misbehaving services, and automatic traffic shifting to another data center. So if you notice, I use the word automatic a lot there. We should, this tired mem of automate all the things, but it is kind of core to what we're going to be doing as DevOps. We need to automate the things, especially the things that we know that a machine can do and that is just tedious and time-consuming for us. But to do those things, we need the metrics. We need that information. We need a constant flow of data that we can parse and then act upon. And especially if you're working in a highly distributed system, automating is crucial to what you're doing. So Istio also offers tracing. It has tracing built in. Is there anyone here using tracing? Okay, a couple of people. All right, so if you're not aware what tracing is, tracing gives you the ability to track your requests through your system. If you have heavily nested applications, it gives you the ability to track how they go through your system, and gives you the ability to track how long it takes to get through your system on each app level. So you can do your tracing with tools like Jaeger or Zipkin. But Istio does the span, which span population is an aspect of open tracing. And then that data gets reported to Jaeger or Zipkin, but it will populate your spans for you. There is one caveat, is that you do have to pass your headers on in your application, or your metadata if you're using gRPC. But this gives you, tracing is a great diagnostic tool. It's not something that you're going to automate against you normally, but it will give you insight into what's going on with your system. It allows you to gather insight in how the traffic's flowing through your highly distributed system, and it's another data point that gives you operational intelligence. So I'm going to go back to this book. All right. So the SRE book, if you haven't read it, right, you should read it because it's free. It's online. The web address is right there, right? And that's economic intelligence, all right? That was a joke. It's bad. But if you're running and maintaining any sort of microservice environment or any sort of highly distributed system, this is going to give you, this is a great playbook for how you're going to operate. All right, and a lot of the concepts that you will see coming down the pipeline when I'm talking about Istio come directly from this book. So, in the book, they say the 4 golden signals, and those 4 golden signals are traffic, latency, errors, and saturation. Those are sort of, those give you indicators of how your application's behaving. It gives you sort of a feedback mechanism of what's going on inside your entire application. I did some work with Weaveworks, and there was a guy that worked there, his name Tom Wilkie. And he, from what I understand, I don't know if it's true or not, he was getting frustrated with a method called the use method. So he came up with his own method, and he called it red metrics, or the red method, which is basically you're monitoring these 3 metrics, your rate, your errors, and your duration. But as you can see, it's very similar to the 4 golden signals. There is some sort of consensus that these are the sort of things that you need to monitor when you're actually working in a highly distributed microservice environment. But why do we do this? Well, we want to maintain that we're meeting our SLAs. We want to make sure our system's stable. We want to make sure we're not going to face cascading failures through our entire system. And we want to automate all the things. But with some of these sort of reactions that we want to have out of the system, they're predictable. Well, we know how to handle these issues. We know, but if we're having a failing application within our system, we want to implement circuit breaking. We want to have timeouts. We want to have rate limits, and we want our individual app to be able to address every other app and figure out if it can connect to it. Because if you have a network partition and you have two subnets that can't talk to each other, that doesn't mean that application can't talk to other applications within its subnet. And I'm sorry, and by the way, this is all provided tooling that is built into Istio. Now, part of the reason this works is because it uses the Sidecar. It uses the Sidecar model. Now, Kubernetes worked with kubectl and everything else on the node level. With Istio, it works on the pod level. So you can give individual attention to each pod. And that means all the traffic that goes in or out to your pod is managed by this sidecar. It is a dedicated manager, and it gives you fine-grained control of every instance of your app running in your cluster. It's like Clippy for your app. All right. Now, stop. One of the reasons we can do this is because of Envoy. Envoy is a layer 3-4 proxy, but it is layer 7 aware, which means it actually can start parsing the packets and actually make choices based on what's going on the layer 7 of the network. So, what it's trying to do is it's trying to attempt to have some sort of operational intelligence on where it's operating, right? So, and it's doing this by parsing the layer 7 to a minimum level, but also doing that the layer 3-4 proxying. And it's looking to get the operational intelligence, but also maintain the performance that you'll get out of a 3 or 4 proxy. All right, and by using this, because it straddles level 7, or layer 7 and layers 3 and 4, and because it directly manages only one application each, you get to do things like targeted request routing based on headers or on metadata, weighted load balancing, canary deployments, traffic shifting, mirroring, authentication, and access management. Before we were talking about reactive policies, where your application would behave, or your service mesh would behave in a way that's reacting to the metrics it's having. Now we're getting the ability to actually be proactive in shaping our traffic and how it progresses through our cluster. So let's talk about my third one, and that's extendability. Going way too fast. So I have two aspects to extendability. One is the application extendability. And this is where Mixer comes in. Go back to the architecture diagram. And we can see that we have our data plane, we have our control plane. In there, we have this application called Mixer. And it is this stateless application that runs inside the control plane. And what it does, and what it says there, is policy checks and telemetry, but it doesn't really get into what that means. So Istio defines its function is an abstract way, the details of different policy and telemetry backend systems, allowing the rest of the Istio to be agnostic of those backends. That's another term I used before, and I think it's not only abstract, but agnostic as well, is really important to the Istio infrastructure and how it's set up. So, it provides two different ways of interacting. It uses this, what they call an adapter model, but it provides two different things, and that one of them is telemetry, where you can actually use telemetry from your service mesh and report it to Mixer, and then you can have it go to any number of different services that you're using. It also has policy enforcement. Policy enforcement means you can do things like quotas. You can specify applications that can only use this much bandwidth, and you can specify that you can only make this many requests to an application before it can't do anything else. But it also gives you the ability to set up access policies as well. Access policies allow you to say what applications can talk to what other applications, not only just in direct communication, but also what methods that they're allowed to do. Can they do get? Can they do post? Can they hit this URL? Can they hit that URL? This all can be minutely managed using the policy system. And they use it, this is all built around adapters. So anybody can build an adapter. If you have a monitoring system right now that you're using that is not listed here, and this isn't the comprehensive list of all the adapters that are available, that doesn't mean that your system won't work with it. You can compile any adapter you want into it, and it's actually relatively easy to build an adapter for Istio. So you can have a reporting mechanism that you are currently using and build an adapter, and now it's deployed to all your applications. All right, another way that I saw extendable on the application level is the sidecar. So Istio was built with Envoy, all right? And it was picked, I'm sure, because of its performance and the fact that it worked on the layer 3 and 4 and actually worked on level 7 as well. But it also now works with Nginx and Linkerd. And one of the reasons that it can do that is because Istio is more of a policy on how to develop. It's not an enforcement. These are pluggable tools that you'll be able to move in and out, and you can replace. If Mixer's not working for you, if it's not performant enough, or if it doesn't do what you need to do, or it doesn't provide the tooling that you need to do, you should, in theory, be able to replace it. These are individual, isolated tools. Istio is more of a policy on how to organize the service mesh. So the last point I have is service mesh extendability. Kind of a stretch of the word extendable there. But so like I showed you before, this is your data plane. And we can run Kubernetes, and that's great. We can run our applications on Kubernetes, and everything works great. But we could also run it on a VM. You can run Istio on a VM right now. And with the new version of 0.8, we can now add another Kubernetes cluster to our service mesh. So, and finally, of course, you can add bare metal. Now, this is called mesh expansion. All of these, you can have all of these platforms integrated under one mesh. They're all talking to each other as if they were right next to each other, as if they were part of the same platform. But they don't know that. And what's important here is that now that we can do that with bare metal and Kubernetes and VMs and everything else like that, we are now giving a lot of latitude. We can now look at our systems like if we have on-premise systems right now, we can now include them in the service mesh. We can come up with hybrid cloud solutions. We can start taking our monoliths that are running on a VM somewhere and start peeling off those applications, because now we can address all those API endpoints individually. And we can start slicing and dicing that application while it still runs on the VM, and it is still part of the mesh. But now your applications are slowly moving to Kubernetes. And we can start shifting solutions across platforms, meaning we can move from ECS to Kubernetes to something else. We can start moving our application, and it becomes a lot easier because our addressing and the way we do service discovery and the way our applications communicate with each other, it's agnostic to the platform it's running on. And finally, it also buys us a certain level of resiliency, because now we can have these different platforms operating together under one service mesh, and we can have redundancy and resiliency for the application itself. So I hope I captured what I thought was some of the main points of why Istio is important. And why is it so hyped? Is that it's not a feature set. It's not the fact that you can, just do route rules based on what version of a mobile app you're using. That's really cool, but it's much more than that. It's the whole architecture has been well thought out, and that means it's going to be evolving as it goes along, and it's going to be a robust system where we can have our applications talking to each other with some sort of assurances and comfort. But I did distill this down to some really, really, really simple concepts of abstraction, intelligence, and extension, and maybe to a fault. And I probably could have gone into some feature sets, but I really didn't feel like that was the core of what Istio is about. So I do feel Istio is the future. I feel like it is where we're headed, but it may not be what we end up with. It's basically set, I think, the precedent for how a service mesh will operate, how the control planes will work, how your data plane will work. It may not be the best solution, but I do think it's going to be it has set the architecture for how we're going to do this in the future. And that's it. A little shorter than I wanted, but. Okay, and thank you for your time. And like I said, I'm Jason Smith. I work with Container Solutions. And does anybody have any questions? Oh, goodness. No pressure.
I don't like the app. So it's the future, but not the present. So what's the gap that you think needs to be closed before we're using it more frequently? Because I've heard from other people that it's not kind of ready for prime time or production use yet. And so I'm interested in, like, what do you think needs to happen before more people can take advantage of Istio itself?
Well, it's under rapid development, and that is problematic, which is demonstrated by the fact that it does have 3 different versions of an API. It has version 1 alpha, version 2 alpha, and version 3 alpha, and a lot of them don't coincide. There's a little bit of overlap, but they are renaming and reapproaching the abstraction they put in for some of the rules that they're using for the Istio system. So that can be problematic. We have seen it being performant. I'm using it with a client right now, and they like it. The feature set is definitely worth pursuing. Things like circuit breaking and all this other stuff, it's just great. But some people may be put off by the fact that it's developing so quickly.
Cool, thank you.
So I guess that answers if it's production ready. Yeah. But also, would you take it to production?
What's that?
Would you take it to production?
I haven't experienced any problems. We are using it on a pretty heavy loaded system right now, but it's not been released in production yet. I wouldn't have a problem with it, yeah, I have no reservations about bringing it in production. I think it's very performant, and I'm waiting. I'm just going to throw this out there now. I was waiting for the question, how does it perform, and how does it affect your latency and all this other stuff? There is a blog post or an article that Istio wrote, and but this actually just leads to a page where it just diagnoses all the steps they go through to measure the performance of what they're developing. And they always are tracking. This is like one of the biggest things that for them is tracking how what they're developing is going to impact latency. It's part of their pipeline.
Great, thanks for that. I wanted to dig in more to almost the final example you gave, which is using Istio as this migration meta mesh between, maybe VMs or Kubernetes or something like that. I'd love you to walk through how that might work, and if you have customers you work with that have done that, that seems pretty interesting.
I have not done this with a customer. I have done this on a machine as a testing environment. It's not really, when you think about it, it's not that interesting. Basically, all we're doing is taking Envoy, just like it's using as a proxy in your pod. And that's just using IP tables. You're just doing the same thing on a VM. And you basically declare Envoy, go declare yourself to the pilot, which is part of the control plane. Go declare yourself to pilot, and now pilot knows where you are, and now it's going to start routing traffic to you. So it's just you put your app just like you do on a pod with a sidecar on a VM. Do you understand?
I understand, thank you.
Could you say Istio is for microservices as important as Kubernetes for containers?
I think Kubernetes, Istio is pointless without Kubernetes. I think you need that abstraction on the hardware level or the VM level before you can get that value of Istio, and so it's sort of a foundation. It's sort of a foundation of what you're operating on. You got to embrace that sort of ecosystem to even consider using something like Istio.
Will the service mesh extension allow us to avoid vendor lock-in?
To avoid vendor, I'm not understanding
the vendor lock-in, like you're committed to a single cloud or
to a single cloud provider. Yeah. I believe so, and I believe there are some big companies looking into this sort of. I don't know if they're looking for to avoid vendor lock-in, but I think they're trying to hedge their bets. So if Google Cloud goes down, Amazon's waiting for them, or Azure goes down, Amazon's waiting for them, I think.
Has anyone thought to implement Istio or similar feature set as CNI plugin?
Yeah, they've talked about it. I think that's been talked about and it's in the works, but because Istio does work over top of the Kubernetes network. It doesn't operate on it. I've heard talk about it, but I only heard it as a rumor. I haven't seen an article that's actually published that says they're going to do that. They might do it.
Any other questions from the crowd? Okay, I'll keep asking. What is the advantage of all-in-one Istio versus individual solution per function?
Oh, you mean like implementing it yourself on a per-app basis?
I guess implementing each one separately and then somehow collaborating independently.
I don't know. Anybody want to?
Policy telemetry, you can probably just look at the market and just pick up a specific solution building block per that function. Just try to choose like the best one, let's say for the proxying, just one HA proxy. So
right.
What would be the reasoning why to get all in one versus if I have to pick up an individual solution buildings block per a specific functionality that
well, I guess it's a balancing, I mean, every time you pick out a new application, it's going to specifically target some aspect of some feature that you want to have, like say Prometheus metrics or something like that. You're spreading your complexity across your system. Istio picked one field it felt like it would be good in, and it's doing a really good job at just that. It's not spreading its interests across everything, and it targeted the things that, at least in my opinion, and I agree with, is it targeted the aspects that are important to the network, which is the metrics and the telemetry that you're going to get out of there to understand what's going on over your system. And using that, and it uses that information to do things that have been widely discussed as part of a microservices environment, like things that are needed for a microservices environment, like circuit breaking or timeouts and stuff like that.
Yeah, and how about security? I've seen that you also handle in Istio identity and access management. Let's say you have your own defined building block for that. Would be any reason to replace that, or could you just do it per function because you have an external package that does handle it for you? like a ForgeRock for your...
So there is a little bit of overhead that comes with the authentication portion of it. Basically, Envoy just reaches, I mean, you can include user authentication into the, to the mixer as an adapter. It's becoming, I think, a little more robust than 0.8. I'm not sure. But basically, it's going to be doing authentication to Mixer over and over again. And usually, a lot of people are using Mixer more for cacheable results. Like if you have applications that want to talk to other applications, Envoy will cache the results. So it gets a little bit more difficult when you're talking about user authentication, on every request.
Okay, thank you.
How does this compare to Microsoft Service Fabric?
I have no idea.
No idea. I kind of expected this.
Hi, one question. Can you draw a line between software-defined networking and Istio? Because some terms seems to be similar.
Yeah, so I think software-defined networks also use this sort of control plane, if I'm correct. Mm-hmm. But Istio gives, because software-defined networks tend to be a little more rudimentary, usually working on level 3 or 4, they don't have that sort of insight into, and this is where a lot of people are excited, some people are excited for it, is it's got insight into the level 7 of the, of the OSI model, where Istio is actually looking at the information as it's coming in and being able to react to it and being able to route based on that information. Mm-hmm. That's one aspect to it. And I also don't know, I'm not that skilled with software-defined networks, but I don't know if a lot of them are offering a lot of the metrics that you're going to get out of Istio. Mm-hmm. So.
Yeah, thank you.
Any more questions? Okay, thank you, Jason.